So this talk is the 12-factor app and the HashiStack. I talk to a lot of people at the HashiConf conferences, and they get excited about all the individual components. There's Consul, there's Nomad, there's Vault, and the confusion comes in, it's like, where do I start? How do I take my application and run it inside the stack? And how do all the pieces fit together? So the goal of this talk is to show you, in a very practical way, how you would assemble all the bits and the things you should do in your app to take advantage of the HashiStack, okay? Now, in this example, we're going to be using this application, right? So this is a web app, talks to a database. So the goal of this, the requirements when you're looking at any of these platforms, if you're gonna do any engineering, beyond the blog post, beyond the marketing, you should take your application and figure out what your requirements are. So for this particular app, I need a username and password and the database URL. Ideally, I want my app to actually stay running, so you may want to scale it horizontally. But these are the things you should be thinking about when you're thinking about adopting a stack. So the goal is to take this application and move it into the HashiStack. Now, I'm going to tell you a little bit about the application. So 12-factor has a lot of good ideas about how you should write an application that lives in this world. And the main ideas behind 12-factor app is to make your app a little bit portable so it can be decoupled from the underlying machine. Now, this is really important because in Nomad, you have the scheduler that's doing the placement for you. How many people are familiar with the scheduler? That's not all the hands, okay? If you have a Linux machine, you should be familiar with the scheduler. It works so well. When you launch your application, that scheduler places your workload on one of your CPUs and it just gets out of the way. It's very good at its job. Now, for those that are not familiar with the scheduler, there's only one way to explain this. I'm going to play Tetris. How many of you have played Tetris? It's a great game. So Tetris is a great way to talk about schedulers. And we're going to play a little game. Oh, so nostalgic. So before you use the scheduler, how many people have fully automated deployments? Like, you're like badass. These are like unicorns. There's like 7 of them here, okay? And they're really proud of themselves, right? Because if you go to work with their company, they show you, like, we run this one script, fully automated. But behind the scenes, there's something happening there. So they hit one button, and then they go out for beers. Then they come back and, like, it's fully automated. But yeah, look at all the memory and CPU. It's totally being wasted. Because most of the times, your fully automated setups do not take into account the resources as they attempt to place workloads on the machines. There's this big static scheduling going on. Now, I work for a cloud provider. We love that. Like, keep wasting resources. Spin up more VMs. So when you introduce a scheduler into your environment, things are a little bit different, okay? What you want to do is then examine the playing field for every workload that comes in. Now, the speed of your scheduler, especially with Nomad, is really going to be fast. But I want to slow it down a little bit so you can kind of see what happens when you decide to use a scheduler. And also, in this world, all the workloads are slightly different, right? Every workload isn't the same. Some things are batch, some things are long running. So Tetris is a good analogy because as the pieces fall down, the scheduler's job is to place these in a way that we leave room for other workloads that come and play. Now, most of you are thinking like, wow, he's really good at Tetris. He's probably going to mess up. No. So what we're doing now is what we call bin packing, and this is something that you see in default with Nomad. So you do bin packing, and the goal of bin packing is to place workloads, so when the right piece shows up, you have room for it on the node. So this logic of scheduling is to make sure that we have room for our most important workloads. And as those workloads run and they exit, then we clear off those resources, and the scheduler can find the best fit for the next piece that comes in. So this is what you're getting when you start to use something like Nomad. Now, I know some of you have existing infrastructures, right? And the nice thing about Nomad is very modular. You can decide to have Nomad not only place maybe your containers, but also your static binaries. Or if you're in the JVM world, there's support for like jar files. So you can actually bring Nomad inside of an existing environment, and that world looks a little like this. So you can get some benefits of Nomad. So Nomad will still attempt to schedule around the free resources in your system. So even though it isn't pretty, Nomad can do a decent job of cleaning things up. And over time, as you move more workloads into Nomad, you start to get the benefits of the resource scheduling inside of Nomad. Now, some of you work at the enterprise. Any enterprise employees here? Got legacy apps? Don't put your head down. If you've ever filled out an expense report and it got paid, it's probably because of that legacy app. Legacy apps actually make money. So don't be ashamed. But here comes the reality. So everything's written in Java 1.4. On top of an Oracle database. So your world is a little different. And the truth is, there is nothing we can do to help you at all. So that's scheduling. And now we're going to talk about 12-factor apps. If you're a developer in the room and you believe in no ops, the reason why it won't happen is probably your fault. The reason why we have all these scripts and Nagios checks is because of the crap you write. I am serious. I've been on both sides of the aisle. So I'm going to show you guys some very simple things you can do as a developer to reduce the amount of ops and hacks that people have to do. Because this is all your fault. You got to own it. I don't believe in blameless postmortems. It's your fault, damn it. I already know whose fault it is. We don't need the whiteboard. His fault. So when we write this 12-factor app, we're going to do some very simple things. Everyone looks at this stuff and says, this is simple, everyone should do it, but you're not doing it. So when I look at this code, this is written in Golang, but the language doesn't really matter. This line right here is important. You see that line right there? Starting the application. You ever launch an app and you're like, what the hell is it doing? This is a good indicator that we have life, okay? So this is the first thing you do. You want to log something. Now, in this Hashi app, and until the next release of Nomad, the best bet is that you're going to have to feed in your token so you can get the rest of your secrets. So if you buy into this idea that you would like to get your secrets from Nomad, you can go all in and have your application actually grab a token and then communicate with Nomad to do that. So here we're going to grab our token from the environment variable. And we're also going to get the address for Vault. Now, these things will be handed to our application via Nomad. And in this world, we're going to assume that things will be populated from an environment variable to make things a little easier. I'm also going to grab some other secrets for other reasons, and I'm also logging that I'm connecting to the database. Now, some other things that I'm doing here is initializing my database pool based on the credentials that I get from Vault. And the other things that I'm going to do is actually check my database. Now, one thing you could do to make ops life easier is don't assume that that database is going to actually be up. You should retry the connection. When it's like obvious, but you don't do it. And then you ask ops to start things in a specific order. There is no reason to start these things in specific orders if you're handling that common case that it won't be there. The other thing that we do in the HashiCorp world is we may have to deal with port conflicts. Now, the scheduler and Nomad can help us with this, but we're going to have to give a little bit of assistance. Do not hard code the port number in the application. There's no reason to do that. There's too many ways of actually getting the port number from the system. And it's okay to have same defaults, but please make it configurable so that way I can move the application between platforms. Some platforms allow you to pick any port that you want. Other platforms are going to require you to take the port that it gives. So Nomad gives us a facility for doing that. The next thing you need to do is also handle the renewal of your credentials. So if you're going to go to Nomad, and we're hiding some of this behind a little bit of abstraction, ideally you don't want to leak this throughout your entire code base, but if you're going to be the app, in the background, you're going to be responsible for renewing the credentials that you want to obtain from Nomad. And then last thing you need to do is make sure that you do clean shutdowns, okay? We look at all these scheduler tools, they spin things up and down, they do rolling updates, but it won't work if you don't shut down cleanly. If you just shut down and crash and leave all your database connections open, that's going to be a problem. So as a developer, you're responsible for doing this part. Trap a OS signal, do a cleanup routine, and then log that you're done or do something reasonable. That way I don't have to work around the application. So this is the app we're going to be working with. If you want to know about more details, it's on GitHub. You can look at the entire code base of how I'm working with Vault and communicating with it. This is what the HashiStack looks like today. We're going to take Consul, and that's going to be the core of our infrastructure. This stores all the cluster state we need to make sure that our app is defined and continues to run. The next thing we need is Nomad. This is our scheduler, and this is the thing that's going to enforce or reconcile the state that we put into Consul. And then we're going to use Vault for secrets. So we're going to combine all of these three things, and we'll see something else on top in the live demo. And this is going to be our control plane. At the bottom here are our worker nodes. Now, these are the things that are completely stateless. We can blow them away. If you're using volumes, you should be able to migrate your containers across these. But I have some opinions about running stateful stuff on this if you're careful, and we'll get to that. But on the nodes, all we need is Consul and Nomad. The thing I like about Nomad, I can actually just schedule static binaries if I want to avoid using containers. So I think that flexibility allows you to adopt this without actually changing too much of your infrastructure. Now, a lot of you have these kind of dreams. I want to be just like Google one day. We have this monolith app. We're going to split it up into, we're going to use any buzzwords today, okay? To services that are smaller than your monolith. So we're going to talk about that. And then these batch jobs. Now, Nomad is highly tuned for this world, where we can get high resource utilization by breaking up our, whether it's a monolith or you add other jobs along the side that can actually take up spare capacity. Without doing that, it's going to be really hard to get the really high resource utilization that you read about. It's not magic. You don't do it alone with a monolith. But then reality sets in, and this is what you actually have, okay? That's okay. If this is your world, this is fine. You're not required to live in this world to take advantage of these tools. You're going to get a lot of benefit out of this platform, even in this world. So don't be ashamed that you're in this world. Don't go and refactor this for no good damn reason. Like, this will cause you pain, I promise you. There's other things involved outside of scheduling workloads that you need to do when you adopt this model. Tracing, logging, everything becomes critical when you move to this. So we're going to start with this. All right? So now let's get on to deploying the application. So I'm going to show you my stack. Everything is reporting into Consul. So right now, don't try to hack it either, because this is being done over SSH tunnel, so you can't log in here and start turning things off. So put your laptops away. So here we have Consul, Nomad, and Vault. These things are all up. They're all passing their checks. So this is the basis and foundation for my platform. Now, the first thing we want to do is start to look at our job. So we need to look at the job we want to deploy. We're going to think about our application first. So the idea here is that this thing will be application-driven, the decisions that we make. So here's a Nomad job file. And in this job file, we're specifying some defaults, like we want to run in the default data center. We want to have a service, so this is going to be a long-running job. And we also have this update policy in place. So here in our update policy, when I need to do a rolling update of the versions, I want to stagger my updates by 5 seconds and run no more than one in parallel. And I'm picking that because I only want 3 copies of my app running, okay? So now we have our Hashi app. And the task that I'm going to use here is the execution driver, which will allow me to just use a statically linked Go binary that I'm hosting inside of my cloud storage. And I give it the SHA-256 to tell me that I've downloaded the right thing before it executes. Now, here's those environment variables that we saw earlier in our application. So we need to populate those. Now, I want to use a unique token per application. So this is one way of doing it. If you want a unique set of credentials for each application, you need to generate a token. Now, in the future, I'm hoping that Nomad will do this for me under the covers. Doing this in my app, I think, is a little bit tedious. And also, imagine checking that token into GitHub. This is not good. If you have your private keys in GitHub, after the keynote, remove them. So we need to generate a token here. So I'm going to go ahead and do this now. So what I want to do, since I have Vault already set up, I want to create a token, and I'm going to do it for this Hashi app. So I have a policy in place. So the idea with Vault is that we want to limit what each application can do. So here's the policy for this application. It can create a secret called HashiApp, so any secrets that I need for my application can be stored there. I'm also going to use the MySQL driver in Vault to give me on-demand credentials to MySQL. If you haven't seen that feature, you should check out the documentation, but it's pretty nice to have that fully automated and managed for you. And also, in order to be able to renew my secrets, I need this last path down here to make sure that the token that I give the app is able to do this. So with this policy in place, we can create a token. So you can probably totally hack me that I'm showing you my credentials right now, but the goal is to take this token, and you need to feed it to your app. And this is why I think in the future we need native integration in Nomad to do this, because we do not want to have to populate this in our application this way. So we're at the token, okay? So we have the token, and now we can talk to Vault. The next thing that we need is our database. How many people plan on running a database in Nomad? Good, everyone likes their job. When you're starting out with these things, it's not that it's not possible, but it's incredibly hard, right? Because MySQL, Postgres were not designed in the world where you move it around all the time. Some vendors will say you can do it. You like your job. Keep it. So what I'm going to do, I'm going to be practical, okay? So Practicality says run your database wherever you're running it. Get the credentials. Right now, I have Vault handling the credentials to this hosted database. Vault can do that for you. And I'm just going to grab the URL to this database, and I'm just going to feed it to my application. Right? So this is being pragmatic. I see too many people spend too much time trying to port their data stores into these systems. And to be honest, you can get tons of value by moving everything else except for the data stores until these platforms catch up and until your operational expertise catches up of dealing with these things in dynamic environments. All right, so we save this. So we have everything for our job configuration for this application. The next thing that I need, though, is if you notice from my job config, I'm referring to Vault by its DNS name. Where does this DNS name come from? How does this magic happen? When Vault comes up, it will automatically register itself into Consul. So that means I need Consul running on all the nodes, or at least some way to communicate with Consul running on the nodes to have this work, depending on my workload gets placed. So we need to put Consul agents everywhere. And what we can do, which is really nice in Nomad, is we can use a job to place Nomad or Consul on every machine. So we'll look at this job for Consul. So this is all the things you need to do to get Consul up and running. So here's my job. I can do rolling updates of Consul when the time comes. Here I'm using a stateful directory. And here what I'm doing is I'm downloading the binary directly from HashiCorp, and I'm giving the SHA-256 to make sure that I'm getting the right payload. And now I'm going to run this as a system job. So this means it's going to run on every server in my environment. So when new servers are added, automatically gets populated there. So let's run this command. So we'll say nomad run jobs. What is this thing called? Consul. All right? So we go through the scheduler. It creates this job on every single node in the cluster. And now we have this running everywhere. So the next thing we need to do is join it to our primary cluster. So we need all these agents talking to the primary setup that we have. So we'll join these. Right? So this is where they're all running. Let's make sure they're actually running before we do the join. So nomad status. And then we'll look at Consul. And we see that all 5 of them are running on every single node in our cluster. All right? So we're in good shape. So now let's join them. All right, so now that everything is joined, if I say Consul members, we see that we have all of our servers and all of our clients active, right? So now we have that foundation that Nomad can use to do auto service discovery for the things that I rely on, and also register my app so they can be discovered, and we'll see that that's important later. All right, so we check our Consul dashboard and make sure everything is checking in okay. So we hit refresh here. We go from, we see our Nomad. Actually, we actually should see, where's my other stuff? It better be working. All right, we see all of our clients there. I don't know if these things actually, the agent should actually show up. We're going to go on faith here that it's working. If that says true, I'm going to assume that all of them are healthy. And we're going to test this out now by deploying our application. So this is what you do in production. Don't ask questions. It'll be okay. So now we're going to take this, and hopefully, if this works, it should run, and if Consul's working, it should register itself and show up in our dashboard, okay? Fingers crossed. Do it live. So Nomad, have you guys seen like the plan feature? This is like pretty awesome. This is the thing you show your boss. He's like, let me show you something cool. You see that? Oh, is that a diff? Damn right it is. So this is saying that this particular job, based on what's currently running in the cluster, we need to create 3 more of these instances. All right, so let's do that now. So we'll call Nomad run jobs HashiApp. So what this will do is run this application across all the nodes, or at least in some of the nodes that can actually fit this particular workload. And we'll say Nomad status. It says it's running. I'm pretty hopeful here. Okay, that looks good. I'm a little more confident. So they're running. Now let's see if it's in Consul. Please be in Consul. Ooh, there's my app. You don't know how relieved you are when you're doing live demos and it works. All right, so our app is now running. This is sweet. So this is the HashiStack. How do you get traffic into the application? Ooh, interesting. And this is where most demos stop. But we're going to keep going. So we need to get actual traffic. The whole point of writing applications is so your users can use it. It's not just to be doing these kind of things. These are cool, but this is not the main goal. So one thing you can actually do is get the status for the allocation, right? So we can get one of the statuses for our allocation to see what IP address it has. And this is how we can test if it's actually working. So we get the status, and we see this private IP address here, and we also see this dynamic port that was handed to us from Nomad. And ideally, if this works, we should be able to call curl and get some data back. So I call curl on this, and we see the hello message. And also, I'm going to check out the version that I have. Awesome, so we see 1.0. But I need this to actually work for all of our customers. So we need another tool. So I'm going to use a tool called Fabio, which will give us a reverse proxy on every single node that I then confront with the load balancer higher up, whether you have Nginx, F5, you're in a cloud provider, and we're going to send traffic across all our nodes because we know that we'll have this reverse proxy running on every machine. So let's deploy that reverse proxy using Nomad. And you're noticing here that we can do all this stuff in any order that we want to. We can layer this stuff on top, and things will work on demand when we need it to. So the thing we're going to do now is run the Fabio job. And it's very similar to what we've seen earlier. We're just going to download, again, I don't know why all of these things are just written in Golang, so it makes my life super easy. So I grab this reverse proxy, make sure I have the right version. We're going to run it very similar to before, and I'm going to put this on every single node. Okay? And if this works, Fabio will be able to discover all of my services by looking at Consul. And now I don't have to do any other configuration to my application. So this is pretty gold if it actually works. So let's do Nomad. Let's do Nomad run, jobs. Okay. So this is also a system job because we want this reverse proxy on every single node and discover all the services and actually spread traffic across them. So if this is working, we'll do a status here. So we see that things are running. Just make sure they're actually up. Good. All of them are running. One is pending. How long will you be pending? I actually don't care. We're going to keep going. And then what we'll come to here is we'll verify that Fabio is actually running. So it is. Okay? So the next thing we need to do is have our load balancer send traffic here. So ahead of time, I allocated a public IP and a load balancer in my cloud provider. So I'm going to go here now and show that to you. And here, actually, my load balancer, I have this HashiStack, and I have this public IP address. So one of my nodes is down. Who cares? We're just going to roll with it, right? And the nice thing is we won't send traffic to this broken node, all right? But we do want to see that this thing is actually up and running. So let's do this, and we should be able to verify that our dashboard actually works for Fabio. So we'll go visit that now. All right, so what you see here is all 3 of our applications automatically discovered by the reverse proxy because it has native Consul integration. When I created my HashiApp job, I also used a special key so that way any traffic that comes in using HashiApp.com will automatically flow to these backend instances. Now, the magic here is that when we scale the application, it automatically propagates to this, no regenerating of files. So we need to scale our application. Let's see how that works. All right, so how big should we scale to? Say something. How many? 200. All right, so we're going to say 200 divided by 20 equals 10. All right, thank you for that. You wanted 10, I'll give you 10. So we'll do our plan again. And again, we get this nice delta. We're going to have to create 7 new ones. We're going to do an in-place update for the ones that are already running. So this kind of gives us a little bit of confidence to know that we're not going to be destructive. We're not going to take down our environment. We're just going to add to it. So given this confidence, we're going to go ahead and run the job. So Nomad, run, jobs, and then we'll do HashiApp. And what this do, we'll go through this evaluation, create all the extra instances that we need, and once they become ready, we see them show up here, so they're all running. So if we swap over here, we should see that we have 10. And we have 9, and that's good enough. We're going to keep, 10, sweet. So we're in business. So at this point, we should be able to hit through our public IP address and round robin between all of these applications, okay? So let's do that now. So we're going to do a little bit of curl magic. So what we're going to do is set our host header to hashicomp.com. And actually, I'm going to give it the public IP address of this load balancer, so that way we can have this thing proxy and see if it all works. All right, so let's set this. So this thing is listening for traffic on 999, and ideally I should take this public IP here, and we should be able to send traffic to it. Haha, we have version 1.0. So now you're at work looking like a badass. You're looking for that raise, it's perf time. Promo's so close. Then they ask you to update all these things. Haha, challenge. So how do we update these things? You notice we didn't do any node placement. We don't know where they're running, but we want to roll to the next version of the application. So the workflow for this would be to produce a new binary, get the SHA-256 of this binary. So in order to do that, we need to make sure that we have a place that we can download it from. So I'm going to go to my Google Cloud Platform, go to my storage, go to my application here. We have V2. And what we need here is this SHA-256. So we'll grab this. And let's just see what this SHA looks like. So we'll do a curl, grab that. Haha, we have this SHA. All right, so now what we need to do is update our job definition here. So here's our HashiApp. We need to update the version of the application to make sure that we pull down the right binary. So we'll come over here. All right, so that's set properly. And now we need to update our SHA-256. Now, you guys ready for my awesome Vim skills? You guys ready? Watch this like, whoo, that's sick. Don't you hate when people backspace all the characters? Like, dude, you're killing me right now. You tell your boss, I can't pair with him. He can't type, I can't pair with him, sorry, I quit. All right, so now that we have our updated job spec, we're going to run plan again to give us an idea of what's going to happen here. So we run our plan, and we get this output saying, hey, there's some differences going on here. So I'll make this a little bit smaller so we can see what's going on. So we see this diff. It's telling us that, hey, there's some things that have changed. New binary, new hash, and it's going to have to destroy and create all 10 of your instances. But the good thing is going to use our rolling update policy, and we're doing clean shutdowns. So ideally, we shouldn't drop any traffic. So we still have our thing running here. And what we're going to do now is go ahead and run this job to see if our rolling updates actually work. So we'll do Nomad run, and we'll do our job, HashiApp. And what will happen is, based on this policy, every 5 seconds, it will roll through, kill one, create a new one. If we had a little bit more parallelism, it would kill 2 and maybe create 2 more. But it's going to go through this. And while this is actually happening, we should start to see 2.0 show up and we're not dropping traffic, right? And the key to this is actually having those health checks so that Nomad can know when your thing is actually healthy, or Consul will. And then also handle clean shutdown. So even though we're shutting down one of these apps, we do get chance to cleanly shut down. We can process that last packet before it's done, and then not return any errors to people. Returning 500s is not a feature. Do not show 500s to your user. Yes, the number is higher than 200, but it doesn't mean it's better. People get confused by that. So it says it's all done, and with that, that's how you use the HashiStack to roll out a 12-factor application. Thank you.